Hello everybody, welcome to Science, Technology and History Explained. Today I'm looking at the electric vehicle versus gasoline, or if you want, petrol vehicles. What are the CO2 emissions and what is the economy in light of the recent developments in gasoline price? How much cheaper is it to operate an electric vehicle? So let's take a look. If we start off with the greenhouse gas emissions, transportation consists a significant part of the CO2 emissions in the world. Also, when we saw primary energy in my energy video, and if we look inside the transportation, how many billion tons CO2 or CO2 equivalent are emitted, then road transport is the biggest part. Then we have shipping, aviation, and very little contribution from rail. So if we could manage, for example, with more electric vehicles, here we could substantially reduce the CO2 of road transport, and especially if we are starting to have more and more green electricity provided. So just looking here at some cars I investigated, I selected the Volkswagen ID.3. This is the car I bought last year, so I have some hands-on experience with this vehicle, a smaller car to commute to work. And then I also looked at a similar size, let's say Volkswagen Golf petrol gasoline car, so much less horsepower, much less acceleration here. It also weighs less, so the battery for electric cars for the equivalent size, let's say, weigh more. And then when we think about the greenhouse gas emissions, we can't only look at what comes out in the operation, but we also have to look at the manufacturing. And here I used the Green NCAP European site that made some life cycle analysis. So Volkswagen Golf, let's say 2021 model, the manufacturing of that I calculated to 8.5 tons CO2 equivalents. This is emitted to produce the steel and everything that's needed for the vehicle. The Volkswagen ID.3, also 21 model, is 17.5 tons, so almost twice the amount of CO2 to produce an electric vehicle. And of that, Green NCAP is saying 7 tons is just to make the lithium ion battery. It's a 55 kilowatt battery here for the electric vehicle. So a significant part of the extra manufacturing CO2 comes from the battery. The consumption, if I look at my own car, and I'll show you in the next slide, is around 0.2 kilowatt hours per kilometer, five-year-old car. And for the petrol car, I used the 0.67 liters per kilometer. That's 15 kilometers per liter. This is equivalent to 35 miles per gallon if you are in the US. So quite a, let's say, not very conservative number for the petrol car. It depends also on how you drive. But as I said, interesting how much the battery itself adds to the CO2 emissions to produce the vehicle. Looking at the consumption of the electric vehicle versus the gasoline vehicle, this is my numbers from my own car. The blue lines is the average consumption I had monthly from the last year. I've used it around 7,000 kilometers, and it's interesting to see the orange is the average temperature in Denmark where I live. And as the temperature goes up in the summer months, my electric consumption improves a lot. But in the cold winter months, we have quite high consumption, average around 0.2 kilowatt hours per kilometer. This is what I've used, and this is based on real life conservative number, not just the list based number for this vehicle. The electric vehicles are really good at stop and go traffic. So if I'm driving, half is highway and half is small roads, and this is really good when it's slow traffic, let's say. But as I said, sensitive to cold weather because we also need to use the battery to heat up the car. An average petrol vehicle is not good at low speeds. It's good at mid range speeds, let's say between 50-80 kilometers per hour. If you're in traffic a lot, your average consumption will not be the 35 miles per gallon or the 15 kilometers per liter as I indicated, but I've kind of used this number here for the consumption. And then if I look at what are the greenhouse gas emissions for the electric vehicle versus gasoline fuel. So in Denmark, the average CO2 emission for each kilowatt hour electricity for 2024 was around 0.1 kilo CO2. Denmark has a lot of renewables in electricity production, a lot of wind, solar, and bioenergy, and only a little bit gas, coal here when we look at this graph here. Gasoline is around 3 kilos of CO2 emitted for every liter. 2.4 kilograms of CO2 are bound in the fuel when you are combusting it on the road. And on top of that, around 0.6 kilograms per liter to produce it, refine it, and transport it to the pump in the destination. So then with all these numbers, if I look at the CO2 emissions over life, and here I assume 15,000 kilometers per year driving pattern. So here we see year zero, the petrol car, the blue line, starts off at 8.5 tons, while the electric vehicle in comparative size starts at almost double that. But each year, 3 tons around are emitted in my calculations here for the gasoline car. So after around 50,000 kilometers, we have a break even where we see the electric vehicle emits much lower CO2 using the electricity that I've been calculating, and assuming also that the gasoline the consumption doesn't degrade over time. Here, this I think is a bit optimistic for the gasoline case, but you see if we keep the vehicle around let's say 10 years, we have almost twice amount of CO2 emitted or for the petrol variant compared to the electric vehicle variant. And of course, the longer you keep it running, the more CO2 you are saving. And the break even around 50,000 kilometers. And then I also wanted to simulate what happens if for example, the gasoline car doesn't run 35 miles per gallon. If it's 25 miles per gallon, then break even comes much earlier. Let's say around maybe 30,000 kilometers here. And then if you're living in a country where maybe in the US it's not as much renewable electricity as we had in Denmark here, but with the values I saw there, we get this dashed orange line for the electric vehicle. So still good, even let's say when half of it is probably non-fossil and half of it is fossil. But if you live in a country where all the electricity is made from fossil fuel, then and you have very efficient a gasoline car, then it doesn't give you a big CO2 benefit to switch. But for all other cases, you are saving quite a lot of CO2 after you reach the break-even point. Switching over now to fuel economy and not greenhouse gas emissions. If I look at the electricity price in Denmark, we have typically the price is depending by the hour. Here is one day when I could charge at home. In the middle of the day, sun was shining that day. I had half a krone, Danish krone per kilowatt hour, and typically I can very easily charge at home for 1 DKK per kilowatt hours. Maximum will be 2.5 if I just charge not from home. And if I calculate all this, the equivalent price would be with a 1 DKK per kilowatt hour. The equivalent price of the gasoline would have to be 3 DKK per liter, or what is 1.8 US dollars per gallon, or 0.4 euro per liter. So very, very much cheaper than the gas prices we have at the pumps at the moment. If I compare to the gasoline price in Denmark, before the crisis in the Strait of Hormuz that we have right now in Iran, it was around 14.5 DKK per liter. Now it's gone up to 16.5 or something like that. and that in US prices, I know your prices are much lower but still high, that would be the equivalent of 8.6 to 10 US dollar per gallon. And in the rest of Europe, if I convert this to euros, it's around 2 up to 2.3 euro per liter. So very substantially much lower price for the electricity here. If I take it at half a krona here, I could be even, let's say, 0.2 euro per liter, if I only charge at the best rates hours. And if I do the annual analysis of the running cost just for the fuel, so if I take 1 krona per kilowatt hour and 16.5 as the gasoline price, then if I run 15,000 kilometers a year, 3,000 krona for the electric vehicle, 16,000 for the gasoline, and this is the equivalent prices in euros and in US dollars. So a fifth of the running cost for the fuel, let's say for the fuel for the EV compared to the petrol. And if I went back and say I take the worst, even if I take the worst case of electricity, and I haven't charged at this high price, and somehow gasoline returns to the pre-crisis in Iran levels, still it's half the price here. So a lot of savings to be done with electric vehicle in both for both economy and greenhouse gas emissions. So this concludes this video. I think it's fair to say that electric vehicles, especially if you live in a country with a lot of renewable electricity, is really a good is overall a good thing for the CO2 emissions. Even taking into account the quite high emissions to produce the vehicles, they are quickly you reach break even, and economically at this moment it's really a strong benefit. So let me know what you think, and let me know how the situation and the prices are in your countries. I hope this gave you some input here, and please press like and subscribe to the channel, where I will bring you a lot of energy and science and technology and energy transition videos like this one. So with no further ado, please stay safe out there, and bye bye.